So good morning, class. This time we're going to answer the graded sheet work that I have given you on the subject statics of rigid bodies, vector forces, and equilibrium of particles. So I guess there are 10 problems that I have given you, and we are going to try to answer them one by one. So we start with this problem number one. The initial velocity of a human cannonball is 25 meter per second, directed 34.1 degrees from the horizontal. What are the x and y components of this velocity? So the answer was given, and all we have to do is to find the solution for this answer, the step by step solution. So we are going to first find the given. The problem states that there is this human cannonball. So so this it's like there's a tank, right? There is a tank, yeah. So the human cannonball, there's a 25 meter per second directed 34.1 from the horizontal. So this is the horizontal. This is the vertical. Then 34.1. So this is 45, maybe like this. So 34.1 degrees from the horizontal. What are the x and y components of this velocity? So this cannonball, there's a ball, right? The velocity is 25 meter per second. That's 25 meter per second. So this is 25 meter per second. What is the component here in horizontal? What is the component here in vertical? So we might use another software so that you will understand here. Yeah? So our given is 34.1 from the horizontal. So we are going to use the CAD, yeah, right? So 34.1, let us say. So this is my drawing. So 34.1 from the horizontal. So let us draw a line here, and it says 34.1 from the horizontal. I think it's a degree. Yeah, it's only a velocity 25, like a 25 meter per second. Let us say, yeah. So let us use the velocity as our line. So there is a line of velocity coming from here, and that is 25, and then the angle is 34.1. Oh, wow, wow. So here, so let us erase the other. So this is a there is this velocity with the 25 meter per second, and the angle is 34.1, right? So if I want to measure the angle, so that you can only, this is just for the illustration, so that you can visualize what is kind of happening here, right? Yeah. So first, we have to measure if the angle is really 34.1. So here is the two lines. right? Yeah. Did you see the angle? 34.2. Oh my God. 34.2. Okay. Now we have to um modify some properties here. 34.1. I mean the text. We have to make it a bit higher, like point 0.3. Okay. Is it current and close? Okay. Yeah, 34.1. 34.1. Why is that? 34.1. 34.1. Yeah. 34.1. Yeah. So as you can see, the angle is 34.1. Okay. And then let me. Okay. Let me have this. Let me check this so that it will be easily visible. So we modify, then the height should be kind of, I mean, maybe one, right, or two. Then set current. Yes. Yeah. So our angle is 34.1, and here we have a velocity that is what is that velocity? 25 meter per second, right? 25 meter per second. Where's that? I cannot find it. Anyway, so there's a 34.1 um, speed here. Let me get it so that okay. Oh, so here, can we accommodate this a bit? Yeah, yeah. I think it is a better kind of better application somewhere here. What we'll put here like this. Right. Okay. So we have to continue. So what we have here is there's a cannonball. Yeah, there is a cannonball, meaning the ball was fired. There's a ball, and that ball was fired, and here is the direction, and the direction is 34.1. Okay, yeah. So here 34.1 degrees. You see this? 34.1 degrees from the horizontal. So this is the horizontal line. This is the horizontal line. And then 34.1 degrees coming from the horizontal. So that is 34.1. Now, we are asked to find the components of this magnitude. What are the x and y component? So basically, the x and y component. Now, if I may use another uh, color, is this. So if we have a 25, if I may, so if I have a 25 uh, meter per second, that is considered as the so-called hypotenuse. the resultant. And then that is that could be broken down to velocity at x we are asked to find, and here there is this velocity of y. Yes. Oh, yeah, I'm not so good in writing. Yeah, so there's a velocity of y. So basically, we are asked to find what is the velocity in x and what is the velocity in y. Okay, so how do we get that? We have the angle. No, we have the angle. So what is that function that we're going to use so that we can find the value of x? So if we have this angle, yeah, so this is 25 meter per second, and that is the angle here is 34.1. So we can formulate a function in trigonometry that is sine of that angle or cosine of that angle, cosine of that angle, let's say theta. Theta is adjacent, no? So that is velocity at x over hypotenuse, which is 25 meter per second. So if we want to get the velocity at x, or the component of velocity at x axis, that's going to be cosine of the angle, which is 34.1 multiplied by 25 meter per second. So that is basically this one, right? So let us use the calculator. So where's the calculator? So here is the calculator. Yeah. So we'll do it together. So here, 34.1. Yeah. Cosine 34.1. So 34.1. This one, right? Cosine. Here is the cosine. Yeah, you see 0.828. 0.828. Then multiplied by our um, uh, resultant speed, which is 25. So multiply by 25 is equal to what? 20.7. So here, if I may use this, so, uy, so here is uh, the answer is 20.7. So if you round up the 20.7, it will become what? 21, no? Roughly 21 meter per second, which is this. Okay. Now we go to the vertical components of the velocity, which is v sub y here. So that line is also equal to this line. So let me have this. Where is this? Okay. Here. Yeah. For example, here. Yeah. Okay. Yeah. So this vector, uh, I mean this is the vector going to the right side, and then this is going to the upward. So this is the resultant. So this is the resultant, and the resultant is basically the 25 meter per second. We are asked to find this. Now, so how do we compute that? Okay, we're going to use this area. Okay, so what function are we going to use if we are given the resultant and we are asked to find the vertical, and we have this angle? So this our angle is the theta 34.1. So if we're going to get the vertical component, our function should be sine, right? Sine theta equals the opposite, which is v sub y. A while ago we already solved the v sub x. So v sine is opposite, which is v sub y over the hypotenuse, which is the 25. We already know this, so 25. Okay. So if we want to get the v sub y, Now visual. Let me use another angle because a bit dark there, and we need to have a contrasting color. So from that equation, from that equation, we could formulate what is Vy. Vy now is sine theta times 25, right? So what is our theta? Sine theta is 34.1, right? Times 25. And what is sine 34.1? So sine 34.1, if I may use my calculator from my computer. Yeah. So let me have this. I'll just clear this. So I think you are looking at this calculator. So 34.1, and that is here. I'll use the trigonometry, which is sine. So what is that? 0.5606. So we will put it here, although in the calculator we're going to use all the function. 56.06 times 25. And what do we have? So here, yeah, 56.06, that is there, yeah. Times we will multiply that with that 25. So we have 14.0159. So here, the answer is, oh, where are we? Yeah, 14.01. Point zero 0.01. If you round up this, it's just more point 14.0, no? So 14.01, that is V sub y, and where is that? Here, okay, 14 milliseconds. So we were able to solve the x and y component of the first problem. So we will go now to the next problem. So here, the number two says, the problem says, calculate the magnitude and the angle. What is this? Example, the initial velocity of a human cannonball has x and y components of 20.7 meter per second and 14 meter per second respectively. What is the speed of the object at what angle from the horizontal was the human cannonball launched? So there was already an answer given, and that is 25 meter per second, and the angle is 34.1. So that's, I think this is just the reverse of the problem number one. So in this problem, the given is the x and y component, which is what I think what we have solved a while ago, right? 20.7. Look at this 20. Yeah, here. Look at this 20.7, right? That is the exact the exact x component, and then it was rounded up to 21. So let me use the exact 20.7. So let me draw. uh, so here, okay. So the initial velocity of a cannonball has x component. So if you have a Cartesian plane of like that, so the y component is 20.7, meaning here, uh, if this the x and y axis, I'll be pulling out another color, right? So if this is the x and y axis, we have an x component which is 20.7, right? The speed, where are we? Right here. So it says there's a 20.7 going here, 20.7 meter per second, and there is the so-called 14, right? My drawing is not up to the scale, but at least it's a representative of our problem in vectors. So here is 14 meter per second. So how do we get the resultant or the summation of this vector? So we will get this if the tail of this, and we will draw another vector. Then here is the resultant vector, right? So we are asked to find this value, right? And the angle as well. So how do we solve this? So let me use this vacant size. Yeah. So first we are going to solve for the velocity, which is the resultant. Yeah. So the velocity, what is the speed or velocity of the object? Let us say that the speed is equal to v, right? So we are given the x and the y component. So we have the 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 20.7 in the x, and then here, somewhere here, right? Somewhere here is the 14. So we are going to get this, yeah. So that is what we are going to find. So how do we find that? It's very easy because we are just since this is a right triangle and this part is the hypotenuse of the tri of the triangle. So we can easily find the 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 value, right? So what is v? So v in terms of the given is like this. V squared, that's the hypotenuse, is the sum of the v component at x squared and the v component at y squared, right? Because that is the Pythagorean theorem. And how do we solve this further? So we can solve this further by extracting the root. If we extract the root here and extract the root here, so this will be cancelled, right? So what is a v sub x? V sub x is what? From the drawing, 20.7. So all we have to do is 20.7 squared, then v sub y. So what is v sub y here? That is 14, right? This one is 14 meter per second. So 14 square. So 20.7 and 14 square. How much do we have? So let me use this. Okay. So 20.7 and 14 square. So let me pull my my calculator here so that you can see how do we solve this problem. So this one is 20. So let me put the exact number, 20.7. Then where is that square? Here, right? Oh, 428.49. So here, let me plug this in. I have I have 428.49 plus what's the other one? 14, right? Oh, 14 square. So plus 14 square, right? So that is 196. Okay, 196. Let me plug this. So if we get the root of 428.49 plus 196, how much do we get, right? So here equals 624.49. If we're going to add these two values, so our calculator says 624.9. Let me have this, right? 0.49, 0.49, right? Look at this. Look at this. Look at the mouse. 624.49. What are we going to do with the 624.49? We're going to extract the root. I'm not so familiar with the equation or with the what is it called this? With the with the um with the calculator, but at least we can square root maybe here. Yeah, 24.99. Look at this. Yeah, 24.989. You see this? This one, 24, right? Yeah. Wait, this one, right? 24.989. So that is in problem number 2. Yeah. So the root of 624 point, let us go up. So the root of 624.49 is 24.909. 24.909. So if round is up, so it is roughly 25. So here is 25, right? 25 meter per second. Now, the next question is, what is the angle? What is the angle? For this, how do we get the angle? So we have this opposite side and the adjacent side. Where do we put this? So here, so that so the, we have this opposite side and the adjacent side, and we are asked to find the angle. Our opposite side is what? 20.7. Yeah, has x 20.7 and y component. Yeah, it's 14. So 14. Sorry. So I have a 14 here. 14 meter per second, and I have 20.7 here. So what function can I use? That is tangent, right? Tangent theta is 14 over 20.7. And how do I get the theta? Theta is inverse tangent or arctangent of 14 over 20.7. Yeah. So let me use the calculator. If we can really have this 14 over 27.7. So 14 is the x-axis. I mean the the y-axis. 14 divided by 20.7 equals 0.67632. What are we going to do with that? We get the inverse tangent. So we have the second function, then trigonometry. Yeah, tangent. Tangent. Where is the tangent? Here. What is the answer? So it should be. Okay. It should be. Let me do that. Uh, Here trigonometry, second function, trigonometry. It should be the inverse sign, right? Yeah, this one. Inverse tangent. You see this? Inverse tangent of inverse tangent. Let us clear first. So here we have this sine function and trigonometry, second function. So tangent, inverse tangent of what? Inverse tangent of this, of 14 divided by 20.7 close parenthesis. So equals, ah, right, 0.67. So let me jot it down. So this one, 14 divided by, let me use this. So theta is arctangent of 14 over 20.7. So 14 over 20.7 is 0.67, right here, 0.67. So we are going to get the arctangent of this, so that we can get the angle. So if we are going to have this, then we go to the trigonometry, then second function, tangent, right? What is the answer? 34.07. So here the answer is, let me jot it down, 34.07 or 34.1, no? So 34.1, right? So the answer is 30.1 and the answer is 34.1. Okay? So that is problem number 2. Okay, so let us see the number 3. vector addition. That is the number three for the graded seat work. So we were given here three vectors P, Q, R. Why? How do we know that they are vectors? Because there is this bar above the letter. So P, right, and then that is the symbol for the vector. So what is the first vector? 5 kilometer 45 north of east. Then Q is 3 kilometer 30 what's this degrees north of west, and R, which is 4 kilometer 60 north of east. So let us try to illustrate that so that it will be um, clear to us. So since this is just a two dimension, we have an x here and y axis here. Now, 5 kilometer 45 north of east. So this is the east. Let me use another pen color so that it will be a bit clearer when there's a contrasting color. So right, 5 kilometer 45 north of east. Na? So there's a 45 kilometer north of east. So this is the east side, north. So north is going there, right? So the angle is coming from the east towards the north, and north of east. So north of east. This is the east. North of east is this, right? North of east. This is the south of east, right? So north of east. Then this is the south side of the east. And the magnitude is what 5 kilometers. So 5 kilometer, and the angle involved is 45 or half of 90. Right. So we finished this. Now the q vector, q vector is 3 kilometer 30 degrees north of west. 3 kilometers 30 degrees north of west. So our concern is west, right? So this is the west, north of west. So here is the north of west. This is the south of west. So north of west, then 30 degrees north of west. So there is this 3 kilometer. So a little bit shorter than 5 kilometers. So here is, yeah, this is the 3 kilometer north of west. Yeah. So this is the north going there. This is the west, north of west. So this is the west, north of west is like this, right? Okay, so 3 kilometer. And then the last one, the R. So what is this? This is the P vector, that is the Q vector, and the R. What is the R? 4 kilometer 60 degrees north of east. Oh, so what's that? 534. Okay, 534. Okay, so now it's the 4 kilometer 6 degrees north of east. 4 kilometers 6 degrees north of east. So this is the east. North of that is again here, right? Going there. So but now there's a 4 kilometer, and the angle is larger, 60. So 45. So then I'll make another. Yeah, here is 60. So from here to here is 60 degrees, and this is 4 kilometer. Okay, so let me redraw that so that will be more clear. So here is the x and the y, and now I'll be pulling out another color to have a contrast. Let me use this. So the first component is 5 kilometer 45 degrees. So this is there, right? So here is 5 kilometer. This is 45 degrees. The other is 3 kilometer north of west. So this is the this is the west. North is there, right? And here is the south. Here is the north. So what is this? 3 kilometers. And the angle is 30 degrees. Yeah, 30 degrees. How much is 3 kilometers? So 5 3. And then the other one is 4 kilometers, 60 degrees north of east. So here, so this is the east. North is there, right? On the top, north. This is the south. And the magnitude is 4 kilometer. So a little bit shorter than 5, but the angle is more steep. Yeah, so this is 60 degrees, but this is gonna be like 4. Okay, so how do we use that? Yeah, how do we use how do we do, do how do we add all those vectors? So we were given the answer, and the problem is how do we find the answer, right? So P plus Q minus R in unit vector form. So why is this P Q minus R? So P Q is going to the positive side, right? So here is positive in quadrant 1, whereas Q, P Q, we're going to follow this. P Q and then minus R. So minus R, and that is the formula now in a unit vector form. So we are going to follow that so that we can use the component method. So we are going to find the component one by one so that we will we will be able to solve the resultant or the summation, which is the negative 1.1 I, or which is resulting in x, and the positive 1.6 j. Okay, so we the solution states that we are going to have to find the component, right? So here is the x component, is the y component. No. Okay. So what is the x component of p? So where is p? So p is here, right? P is here. Here. So p is here. How do we get the component of p? So let me use this space above so that we will understand. So P. So the P component, we have the X and Y, which basically X is the I and Y represents the J, right? In vector form. X and Y is the coordinate, right? So how do we get the PX, right? So here, P of X is this, right? It's 45 degrees, the angle, and 5 kilometers. So how do we get this? So we should get that by having this p cosine 45, right? So here, so there is 45. Here is the 45, and here is the angle 45. Here is, sorry, here is what 5 only. So in order to get the x component of this, x component of this, how? So we should get the hypotenuse, which is 5, then the cosine of the angle, which is cosine 45, right? So this one. So 5 cosine, the 5, which is the hypotenuse, times the cosine of that angle will give you the px, no? P bar x, p cosine 45. Now, what is p 5 cosine 45? So we can show that in the calculator, no? So that we would be very clear for this particular problem, and that is 5 cosine 45. So 45 degrees cosine. Where's that cosine? Yeah, trigonometry cosine. So we are given this is 0.707, and let me jot down. Yeah, so cosine 45 is 0.0707 times 5. So we just have to multiply that by 5. Look at this. I'm going to use the whole number, the complete number, yeah, given by the calculator. I just have to multiply this by 5. What is the answer? Look at this, yeah, 3.53 or 535. So the answer for this is 3.535. So this is 3, this is 5, so 5 above, 5 starting from 5 and above, then you can just add here, yeah. So you can round up here, 3.54. That's why it's here, right? So here, what is another component that we can get from this P? So the y, yeah, so these are the x, these are the y. So let me just solve the y, and then the others are just the same, yeah. I just would like to detail out the first, and the rest are the same. So here, if you were given this angle, which is I mean the triangle, which is right triangle. Let me erase this. Yeah, okay. So if we are given a right triangle like this, right? So we know that this is the 5, the hypotenuse, and this is the x component. We already solved this, 3.54, right? So we don't know this, but we know the angle, right? This is 45 degrees. If we would like to know this side, the function is only the sine, right? Sine of the angle, so sine of 45 degrees, then opposite. What is the opposite? That is the p sub y over the hypotenuse, which is 5. So in order to get the py, we just have to cross multiply only this, right? This portion. So I'll write it here. So py equals sine 45 multiplied by 5, right? So what is sine 45? Let me use the calculator. So here is the calculator so that everyone can see. Um, 45, let me clear this first. So 45, right? 45 sine. Okay, this one, right? So sine 45, oh, it's the same. 0.707 because they are in um, 45 degrees. Yeah? So remember, in 45 degrees function, the sine and cosine are the same. No? 1:1. Yeah, because sine 45, the half of 90 degrees. Sine 90 degrees is 1. Yeah, yeah. So here is 0.707 multiplied by 5. So why don't we multiply this by 5? We still have the number, so we multiply this by 5. Look at the screen. Then if we click the equal sign, 3.535. So the answer is 3.535, right? So 5, you put it here, the round up, so 3. Okay? So same thing with Q and same thing with R. What did they have to do with the Q? Where is our Q? Q is 3 kilometer, 30 degrees north of west. So this is the west. West is here, the opposite of east. So this is the west. North is going there. So your magnitude is here, 3 kilometers. Then here is the what? The angle is 30 degrees. So 30 degrees, cosine of 30 degrees multiplied by the hypotenuse, 3 is 2.6. Then if we go to the y component of q, yeah, so this is q x, this is q y. So how do we get that? We just have to multiply the hypotenuse and the sine of that angle. So hypotenuse 3, then sine. Instead of cosine, we have to use the sine because we are talking about the opposite here, right? So this is the sine function, opposite, then cosine here, sine here, right? And this is the hypotenuse. So this is the opposite, this is the adjacent. So if we're going to do that, we will have this number 1.5. Then same thing we have to do with R. What is our R? 4 kilometers, 60 degrees north of Ising. Now same with the first quadrant and the P. The only difference that C, this has 60, the other one is 45. So it's a bit larger in angle, 60 degrees, and a bit smaller in the magnitude. 5 becomes 4. So here is 4 kilometers, 60 degrees north of east. So this is the east, north of that is there, right? North. So that is 4 kilometers. So if we have this angle, 60 degrees, we just have to multiply the sine of this angle times the hypotenuse. We have this opposite side. Then hypotenuse is 4 times cosine of that angle, which is 60. We will have this side. So what are we going to do with this? We are going to algebraically sum up. We got the algebraic sum of this because here is the resultant or the sum. So 3.54, right? 3.54 plus, or I mean minus 2.6. Why minus here? Because this is 3.54 p sub x. So p sub x is positive going to the right, and then plus q. What is q? Q is going to the left. So q is going to the left. That's why it's negative. Yeah. Then r. What is r? R is what? Mm, R is here 2. No, but why it is negative? Because the equation, yeah. Find, this is our mother equation. So find the P plus Q minus R. So this is what we're going to implement. This is what we're going to follow, yeah. So plus negative, so we have to, yeah, deduct. So minus, right, minus R, minus R, so minus 2. This is the R, okay. So if we add this 3.54 minus 2.6 minus 2, we will have a 1.1 negative. Why is that? It's because here negative 2.6 minus 2 is negative 4.6, right? And this 3.54. So negative 4.6, this is the larger entity. Then plus 3.54, you will have a difference of 1.1, but this one is in negative. So negative 1.1 I kilometer, because we're dealing with kilometer, right? So this is here negative in terms of x, right? Because these are all x components. So negative 1.1, where is that? So if we have a scale, negative 1, negative 2, so somewhere here, right? So this is x, negative 1.1 in quadrant 2. No, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. What about the y? So the y, we have to get all the y components, the 3.54, 1.5, and 3.46. Then we plug there in the equation PQR, but y components. What is the piece of y? Piece of y, piece of y, yeah? P, but the y components. So 3.54, we have positive, and then plus q. Where is q? So q is in quadrant 2. So q is in quadrant 2, negative there, but positive there. So y is positive. So 3.54 and 1.5. Then the last is negative r, non-negative r. So what is our r? 3.46, but we have to use negative because that is the equation given to us. That is this. Yeah, so here we plug the 3.54. Look at this. Yeah, so let me change the color. So 3.54, we have this, right? 3.54. We add the 1.5 for the Q, 1.5. Then minus R. So minus, this is the minus, then R, 3.46. 3.46. So if we add this 3.54 plus 1.5, that is going to be 4 point, what's that? Or 5 point something. So let me add that. 3.54 plus 1.5 minus 3.46. So here is 3.54. As you can see, 3.54 plus 1.5. So as you can see, we have a 5.04. Yeah, if we add this, right, we have a 5.04 value minus 3.46. Minus 3.46. So we go there. Uh, if the number is still active, 5.04 minus 3.46. 3.46. As you can see, 3.46. We deduct 3.46 from 5.04, it becomes 1.58. So the value here is 1.58. So we just round up, yeah, 0.58, right? So zero point 0.5, then this is 8. It's more than 5. So this one becomes 1.6. 1.6. Yeah. Okay, so there is 1.1 kilometer. Where do we put that? The resultant is this. The summation of addition is this 1.1 kilometer to the negative, right? So 1, 2, 1, negative 1, negative 2. So this one, negative 1.1 kilometer, then 1.6 here, yeah. So 1, 2, 1.5, 1.6. Yeah. So here, so this is the point, the coordinate of that point, yeah, is negative 1.1 and 1.6, yeah, negative 1.1 and 1.6, 1.1 and 1.6. So let me use the CAD so that you will see, no? Negative 1.1 and 6. Let me erase this. Yeah, so negative 1.1 and what is that? Negative 1.1 and 1.6. Okay, so here negative 1.1. Yeah, so let me let us have the point of from the origin. So negative 1.1. So if we have a line, mhm, okay, this the summation in the vector is negative 1.1 plus 1.6. Negative 1.1 plus 1.6. That is the summation of the vector negative 1.1 as the of x and 1.6. So negative 1.1. So here is this, right? So line, I want to have a line, this one, right, from here, yeah, going here, right, because it's negative. So I may have this 1.1, correct? Where's that? Let me change the color so that you will see. So properties, let us have a bit, yeah, blue color, yeah, right. So 1.1. Is that this one? So 1.1. Mhm. Let us use the cyan. Yeah. So how do we know that it's 1.1 to the left? So we can measure the linear. Yeah. So from here, from the origin to here. Uy, it's very big. 1.1. Oh my gosh. So 1.1. Yeah. And the other is 1.6. So if we have a line here, yeah, going up, we'll put a 1.6. Okay, here. So we'll have this as this, right? Yeah. So here is 1.1, the other is 1.6. Yeah, so let us measure. So the recent input is this dim linear 1.1, and here is 1.5. God, why is that 1.5? It should be 1.6, right? Sometimes the AutoCAD is, I don't know, yeah, so 1 point, assuming this is a 1.6, that's correct, yeah, 1.6, yeah. So this is 1.1 negative and 1 point, so where do they meet? Yeah, so 1.1 here, then 1.16 here. So here, right? Okay. Nakapo, it is in the polar snap. So 1.1, yeah. So line here is 1.1, right? Mm, off. So here, if we have this, okay. So this is 1.6, right? So from here, if you are going to project, and then here, yeah. So if we're going to project this, so if we are going to project this line, you can have that intersection, right? I think it's under snap off. Yeah, here. Okay. So this value here is 1.1 as we can see here, and this value is 1.6. So that means this is the resultant vector of the three component. Now this somewhere here. Okay, somewhere here in this. intersection. So let me catch this. Let me, yeah, so that we can copy this, right? And then we go to this. Okay. So this is our solution. Then we just have to put this right in a vacant, right? Yeah. So and we'll have the yes, yeah. So this is our solution. Meaning we have a negative 1.1 here from the origin. The from the origin we travel to the left, which is negative 1.1, and then that is the on the x-axis, which is represented by I, and then the j or the y is here, which is 1.6. Yeah, so here is 1, then 1.6, which is positive. So if you project this, yeah, here, somewhere here, then negative 1.1, this. So this point here is the coordinate, yeah, from the origin. This is the resultant. This is the resultant of the tree, which is if you add the x component and the y, then coming from the origin, because we start with the origin as a reference. Is this one. Oh, yeah, yeah. So this, the coordinate of this is in I or x, negative 1.1, comma, and the height is 1.6. Yeah. So that's the summation. So this vector here, that is the summation. Yeah. Or yeah, the summation. So that is the solution for that. Yeah. So that is problem number 3. Yeah. Problem number 3. We go now to problem number 4. What's problem number 4? Given the following vectors PQR, look at this PQR. So the PQR, every vector, we have to add the components, and the I only represents the x, and the j is y, and k is z. Yeah. So for every vector, there is a component in x, y, z, x, y, z. So look at this, x, y, z. No, negative 2 plus 3, 1, 2 minus 3. So they have the same magnitude. Yeah, magnitude. For the x is 1, 1, 1. For the y is 2. For the z is 3. But the difference is the location, no? The direction. Because the here, positive 2, then in the q, negative 2, then positive 2 again. In the z axis, yeah, positive, positive, then negative. Yeah. So if you are going to plot that, and if you're going to get the summation, because it says addition, no? Addition component of vector. So you have to follow the instruction. The instruction is 2p plus q minus r. So you have to multiply twice the p, then you add the q, and then you should deduct the r. What is p, by the way? So the p is this. Yeah? So p I plus 2j plus 3k. So this one, I plus 2j is plus 3k. So this one is our p. What do we have to do with the p? We have to multiply by 2. So 2, 2. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Then you affix the I, J, K. So that is true with the p. What about q? Yeah, q vector. So the vector q is this here, right? So it doesn't change. 1 is to 1. 1i minus 2j plus 3k. 1i minus 2j plus 3k. So we don't have any problem with this. What about the r? The r is like this. Yeah, so it is preceded by negative sign. So here, we should precede all this by negative sign. The I, 1i plus 2j minus 3k. So 1i plus 2j minus 3k. We are going to precede this with a negative sign. It is this, right? Here. Negative, and then this positive, there's no problem, and the other is twice the p. So twice the p is this, right? So 2p bar is this. So here you copy this, you put where? You put here P, right? 2i plus 4j plus 6k. Now, what do you have to do with this? All the components in ijk are given already in terms of P, ijk, in terms of uh, Q, it's also already given. And then in terms of R, it's already given. So all you have to do when you're dealing with vectors here, you add the components of all the I and the J and the K. Yeah, so I'll collect all the I. 2I plus 1I minus 1I. Okay? So here, let me have this. So 2I plus 1I. This preceded by sign, negative. So negative 1I. What is common here? I, I. Right? So I'll take out the I and then I add the following. Distributive, right? So 2 plus 1 minus 1 I, right? So this is the I. 2 plus 1 minus 1 plus 1 minus 1. So it is just becoming as 2, right? It's 2. Okay? Now here, we go to the J component. Now this is the I, right? So I. We go to the J component so that you will understand. So 4J minus 2J, then minus plus 2J is minus 2J. So I'll put it here. So J, so 4J, then next minus 2J, then this one minus plus 2J, so minus 2J. So minus 2J and minus 2J is minus 4J, then this 4J cancel is 0. So for the component of Q equals 0, P, the I component is just 2, right? What about the K? So we go now for the K. Let me have this. So all the K components. So we have the positive 6K, 3K, and what is this? Minus 3K. It will become plus, right? This one. Minus 3K will become positive because it is preceded by by negative here, right? Look at this. This one, right? So K, all the K we collect, yeah, because the minus R here, right? Here, let me emphasize this here. Minus R. So all this R, right, is preceded by the negative sign, so which is this, yeah, so here. So we collect the K. So where do we find the K? This one, right? Plus 6K. Then here, plus 3K. Then here, minus, because minus R, minus this one, right? Minus 3K. So plus 3K. Okay? So what is the common here? K, K, and K. What, what is this? What is this? Minus, yeah? So minus 3K. So it should be plus 3K, and not 36. Yeah. So the common is K. I can have the K. Then I'll have this because it's distributive. To get the 6K, I have to have 6. To have the 3K, I have to add the 3. Then to have the 3K again, I have to add the 3. Right? So K, right? So what is this? K, no? So 6K, I'm just checking if we're correct. Then plus 3k, then plus 3k, right? So here, how do we add this? 6 plus 3 is 9, plus 3 is 12. So here is 12k hat. So 12k hat is this. Then the 2, this one, 2i is this, 2i. There's no j component because it's 0 here, right? So 0. So the answer is this, yeah? 2i, the answer is this. 2i hat means the approximation, then plus 0j, so 0 times is then is 0, then the other is 1 is 12k plus 12k hat. This one, 2i plus 12k. So that is how we add, no? So here, vector addition in component form. So what's the difference with this with the rest? So this now is in component form. So how do we add this? We were given again three vectors with the same magnitude, 1, 2, 3, 1, 2, 3. The only difference is the direction, yeah, because from positive to here it becomes negative, then positive again, then here is positive, positive, then negative. Nah? But what are we trying to satisfy is the equation given to us. How do we satisfy this? We have to solve this p plus q plus r. So we just have to add this p, q plus r. So in vector component form, in vector component form, we just have to add the square of their each vector component, and then we extract the root. So here, as a sample here, 1, then 2, right, square, so it becomes 4, this one, then this becomes 9, right? So that is the solution. So 9 plus 4 is 13, plus 1, 14. Okay, so that is in the P, right? P. What about Q? What about the Q? So let me tag this as Q. So Q has 1i, negative 2j, then plus 3k. So let me square this before we get the extract the root. We first square everything. So 1 is square plus this one, no? Negative 2 times negative 2 is positive 4, so we don't have problem with that. Then here, 3 square is 9, so 9. Okay, so 9 plus 1 is 10, plus 4 is 14, which is square root of 14, no? Because there's a root here. Then the last is r, so 1, then plus 2 minus 3k. So when you try to get the sum of the square of this before you take the root, so 1 square is 1, plus 2 square is 4, then negative 3 times negative 3 is 9, percent by 9, no? So 9 plus 1 is 10, plus 4 is 14, which is exactly this, right? So we have the root 14, then here is square root of 14, square root of 14, square root of 14, square root of 14. All we have to do is just to add, because here, right, p, q, r, we get the each component, yeah, and then we just have to add. So here, square root of 14 plus square root of 14 plus square root of 14. So 3, because we have here at the outside, there's a coefficient 1, this is 1, and this is 1. And the inside is 14, so 3 square root of 14. Okay, so I think that's enough for now. Before we go to the other